In section 3.2, we want to cover measures of dispersion. Now, what is dispersion, first of all, and why do we have to cover it? Well, if everything was exactly the same, life would be very boring for us in statistics. Matter of fact, there would be no need for statistics. So dispersion is another way of saying, right here, you can see it, variability, scatter, or spread. Of those words, we say spread the most often, but if you say to a crowd disperse, it means you are telling them to spread out, right? So that's what these are measures of. Because if you don't have spread, if you don't have variability, then there's no point to having statistics at all because everybody is exactly the same, right? But that's, of course, not realistic. In real life, data sets are spread out, which means their distributions are stretched or squeezed. So the four measures of statistical dispersion we are going to learn are range, variance, and standard deviation in this section, which is section 3.2. And then we're going to learn another one in section 3.4 called interquartile range. So we'll learn that one then, and these three right now. And this one will be a little bit later. Now, dispersion is contrasted. Usually, dispersion is not the kind of thing that we do on its own generally. We're usually using it to contrast it with the location of the average, the center, right? And location of center is measured with mean or median. I could say mode, but we don't use mode for this particular application. So when you're using your measure of spread, you're usually comparing it and contrasting it with the mean or the median. So I guess I should just say mean or median. That's what we're doing. And then we use those two together in combination to kind of describe that distribution. All right, now before I go any further, I have this lovely picture from Wikipedia, thank you Wikipedia, in regards to dispersion. And I just wanted you to kind of see what we mean here. So this red graph right here is not very dispersed, right? It's really squashed, right? So it's going to have a smaller measures of spread, right? It has a small spread to it because it's less dispersed. And it's more packed in. Or clumped together, I guess you could say, right? Or squeezed. Oh, there's the word, squeezed. Right? It's more squeezed together. It's less spread out, right? And you don't quite know what this means yet. SD stands for standard deviation. You don't quite know what that is, but you do know that that's why this has a standard deviation of 10, which is a smaller number than the other one, which has a larger standard deviation. This blue curve has a standard deviation of 50, right? So that blue curve has a larger spread. Larger spread, it's more dispersed. And that's why the standard deviation is 50, which is a larger number. 50 is larger than 10. The blue curve is more spread out than the red curve. At its heart, that's what standard deviation is. It's a measurement of that spread. There's more to it, of course, with like, what do you mean? How does it measure spread? But that is the heart of it. At its heart, standard deviation will measure spread for us. And if you're thinking, it seems like standard deviation is really important. Oh, yes. Standard deviation is the most important of the four measures of spread that we learn. Standard deviation is the one we use by far the most often. So if you want, you could put a little star next to standard deviation because it's a very big deal. So what we could say at this point, we don't really know what it is, but we know that the standard deviation is a number that measures spread. And you can already see the bigger the number, the more spread out the data set will be.